We are continuing our discussion of a representative system, and we're going to observe how a simple program is executed. And in order to do this, we're going to need to utilize the two major components of a computer system, and the first one here is computer hardware, and then we're going to need to use computer software. And the software that we'll be using is going to be just that very simple program that we just looked at, where we had an input, an output, and a jump command. But before we do that, we're going to need to discuss a bit about our hardware configuration here. We have added two external chips to serve as our I/O ports. Now, I/O is for input, output. And a port is simply a method for data to be either inputted or outputted out of a PC, and the port is the place where it either goes in or goes out. The input device is simply an 8-bit buffer. So here we have this 8-bit buffer that's going to serve as our input device, and the thing that will enable this will be we need to have a high on EN1 and a low on EN2. And when that occurs, then the inputs, which we have just simple switches here, will be connected to the data bus. And so when we have this, okay, remember this is from the address bus and the control bus, when those controls are set, then the microprocessor says, okay, feed me input, and then these inputs will feed through the system to the microprocessor. And these are tri-state buffers, so in the event that you don't have the high and the low here, then this data will not interfere with, they'll just be high impedance, and the data will not interfere with other things that are going on in the bus. Now, the output port up here is an 8-bit latch or register. Whenever the two enables are active, low in this case, the input data bus is latched to the output. So if we have a low here and a low here, then the data from the microprocessor is latched to the output, and we have an output feeding to our output port. We have two LEDs here that would indicate that we have an output. And again, the output will only be enabled if we have a low on EN1 and a low on EN2. Okay, over here we have an oscillator, and this provides the clock pulse necessary for the microprocessor to operate, because the clock has to have a speed that it operates at, and this will come from an oscillator of some type. Usually this is a crystal, and very typically the crystal will start at a relatively low frequency, and it'll be multiplied several times to provide the specific clock frequency that the microprocessor is designed to operate. And this could be, a few hundred megahertz to thousands of megahertz, and thousands of megahertz would be, we're talking about gigahertz possibly. Many microprocessors multiply the clock internally for high-speed operation. Okay, finally, we have the reset input, and this is the reset right down here. We shall assume that our representative microprocessor goes to, and that's going to be 000H, and that's for hex, when the reset pin is pulled low. This is to say, when we activate reset, we will force the program counter to 000H, and then it's just going to begin to execute the commands that start at 000H. And okay, we also have a ROM right here. This is an abbreviation for read-only memory. This type of memory device retains its memory even when no power is applied. For this example, we will assume our program is stored in ROM. The microprocessor cannot store new data to a ROM, hence the name read-only. So here we have a ROM chip, and this is typically when a PC starts up, it will go to a very specific address. It's usually not this one, by the way, but we're using this one for our purposes. But it will go to a very specific address and begin reading information from ROM, and this is fed into the microprocessor, and the microprocessor will execute the, for example, the power on self-test. That's not an issue for this course, but it will start the computer, and when it finishes this post program, it will call the operating system, and then the operating system starts up, and then we will have a PC operating. Okay, so this is we're in the next section. We're going to talk. We mainly introduce the hardware in this section. The next section we're going to be introducing how is it that this software program can interact with this hardware.